Hello, and welcome to 24 Hours of Pass, the Summit Preview 2018. We're excited you can join us today for Frank Gill's session, The Transaction Log for Developers. This 24 Hours of Pass consists of 24 consecutive live webinars delivered by expert speakers from the Pass community. The sessions will be recorded and posted online after the event. You will receive an email letting you know when the sessions are available. My name is Jennifer Mosier, and I am the president of the Redmond SQL Server User Group at the Microsoft campus, formerly known as the Pacific Northwest SQL Server User Group. I represented Microsoft several years on the Pass board, and when I left the company, I decided it was time to consider continue supporting the community by stepping up and supporting the local SQL Server and Data Platform User Group. Now I have a few introductory slides before I hand over the reins to Frank. Next slide. So if you require technical assistance, please type in your question into the question pane located on the right side of your screen, and I will assist you, or the functional assistant will as well. This question pane is also where you can ask any questions throughout the presentation. Feel free to enter your questions at any time, and once we get to the Q&A portion of the session, I'll read your sessions out loud to the speaker. You are able to zoom in on the presentation content by using the zoom button located in the top of the presentation window. Also, please note that there will be a short evaluation at the end of the session. Your feedback is very important to us, so please take a moment to complete this survey. This will pop up after the webinar ends in your web browser. I would like to take a moment to thank our presenting sponsor, Quest. In staging 24 hours of Pass, the staging of 24 hours of Pass would not be possible without the generous support of Quest and our other sponsors. And the reason these companies are the reason why we can present this material to you for free, for no charge. If you'd like to learn more about Quest and sign up for information on how they can help you, please visit the sponsor page of the 24 Hours of Pass website. Next slide. In a moment, we'll speak, and I'd like to remind everyone that PASS is a global not-for-profit association where data professionals connect, share, and learn. Joining PASS is free, and it gives you access to hundreds of hours of free online content, live, virtual, and in-person events, the ability to join local user groups in your area, and the opportunity to attend the annual conference, PASS Summit. PASS, the organization, is a great way to connect with like-minded professionals, increase your technical expertise, and grow your career. Next slide. Now I'd like to introduce Frank Gill. He's presenting this next session. Frank is a senior data engineer at Concurrency with over 19 years of IT experience, with the last 10 years working on SQL Server. When not administering databases or geeking out on the internals, because who doesn't, Frank volunteers at the Art Institute of Chicago, the PAWS Chicago Animal Rescue, yay, and reads voraciously. And without further ado, here is Frank Gill with the transaction log for developers. Take it over, Frank.
Thank you, Jen. And thanks to everybody for joining. Just a couple of things to follow up on what Jen said. PASS is an amazing organization. If you're here, I'm assuming you know what, at least part of what the organization does. It's a great opportunity to learn, and it's also a great opportunity to get to know other people in the community. And if you are at an event like this or at an in-person event and you see someone who you know via blogs or books, talk to them and ask them questions, because they will talk to you. And that is how I've gotten kind of drawn in, and I've learned a tremendous amount and my career has gone places that I did not think it could prior to getting involved with the community. So with that, just want to get into the agenda. So the presentation is going to be about the transaction log with a focus on how code can be written to optimize performance. So I'm hoping to teach you how the transaction log works with an eye towards showing you how you can write your code to make it perform better by doing it the way SQL Server expects it to be done, or the way SQL Server does it best. So we're going to step through, I'll talk about what a transaction is in terms of SQL Server, and then how transactions relate to ACID properties, which are properties that underlie any relational database system. I'll talk about transaction log architecture, so how the transaction log, when it is written to disk, what it looks like internally, and part of that architecture are logical units called virtual log files. I'll probably say that once, and then I'm going to refer to those as VLFs from after that first reference. I'm going to talk about a concept called log space reservation, and why log space reservation is a reason that batching transactions can really help optimize performance. And then finally, I'm going to talk about rollback activity, and that also plays into the idea of batching transactions. So with that, just talking about what a transaction is. So you can think about a transaction as a unit of work in the database. And SQL Server does all of the work it does in transactions. Anytime that you're updating, inserting, deleting data, all of that activity happens within a transaction. Anytime that you're updating or modifying a schema, that work happens in a transaction. Backups, restores, there are a couple of other commands that SQL Server performs them in a transaction, but you can't deal with them in the same way as others. And I'll talk about those as I get deeper in. All transactions begin. So when you run an insert statement, there is a begin transaction that starts that transaction off prior to any of the insert activity going on. And then there are two different ways that a transaction can end. It can either commit or it can roll back. And I'll talk about the difference between those two things. And then all transactions are tracked in the transaction log. The transaction log is a sequential file that tracks all of the transactional activity within the database. So a little bit more information about transactions. You have two different types of transactions. You have an explicit transaction, and the explicit transaction, you actually code a begin transaction, have your SQL code, follow that by a commit transaction. And that gives you full control over what is contained within that transaction. And then the second kind of a transaction is an implicit transaction. And that is where begin transaction and commit transaction are not explicitly coded, but SQL Server inserts them into the transaction log. So the default behavior in SQL Server is auto commit. So if you are in Management Studio and you write a delete statement, you say delete from table, and you don't give it a where predicate, when you hit execute, it will begin that transaction and it will delete all of the rows in that table. And when it is done, it will commit them. So it works differently than other relational database management systems, but just know that that is the way that SQL Server works with auto commit. Like transactions, you can either commit a transaction or you can roll it back. And there are two different types of rollbacks. You can either explicitly code a rollback. So an example of this is if you have error handling logic in your code and something goes wrong in the middle of an insert or an update, and you kick to your catch block, you can roll the transaction back. You can actually say rollback transaction, and it will roll that back. If you kill a transaction, say you kill the session associated with the transaction, or SQL Server crashes for some reason, that can cause an implicit rollback of a transaction. So From transactions, we'll jump to the ACID properties. And as I said, the ACID properties are properties that underlie any relational database management system. And ACID is an acronym. The A stands for atomicity. And atomicity means that transactions are all or nothing. If you start a transaction, it has to commit before it can be written to disk. So for example, if I write an update statement that is going to update 100,000 rows, and I get 50,000 rows into that update, and my SQL Server crashes, the instance stops and restarts. On restart, SQL Server will roll back those 50,000 updates because you can't have a transaction go halfway. So SQL Server uses the begin transaction, commit transaction to maintain atomicity. Consistency states that a transaction has to bring the database from one state, consistent state, to another. So if you think about things like foreign keys, if you're doing updates and you have foreign key relationships that have to cascade through, the transaction has to make sure that all of those relationships are managed within the transaction. And so that is consistency. Isolation states that transactions cannot collide with one another. So if I'm running an update statement and somebody else comes through and tries to delete the rows that I am updating, I will have a lock on the rows until my transaction commits, and then the delete can run. And SQL Server uses both the transaction log and locking to provide isolation. And when I start looking at actual transaction log records, I'll show you how locking gets written into the tran log. And then finally, the D stands for durability. And durability states that once a transaction commits, so I have my begin transaction, I do my work, the commit transaction runs, the changes associated with that transaction have to be durable in the database. So for example, if the database has at least two files, you have a data file and a transaction log file, when you're writing those transactions, you're writing into the tran log. On commit, the log records associated with that transaction will be hardened to disk at that point. The data pages that are associated with the transaction can remain in memory because SQL Server does everything it can to optimize its use of memory. So I have that transaction, I've updated pages in the data file or that have been read into memory, and I commit my transaction, log records harden to disk, and my instance crashes before the pages associated with those changes write to the data file. So what happens when the instance comes back up, SQL Server scans through the transaction log and it looks for two different things. It looks for transactions that committed and didn't harden to disk, and it also looks for transactions that were in flight when the system went down. And so it will roll forward the transactions that committed but weren't hardened to disk. So it'll effectively update the pages associated with that transaction in the data file, and then it will roll back the transactions that were in flight. And I'll have a demo at the end of the presentation to demonstrate what that looks like. So from there, we'll get into Tranlog architecture. So as I said, when you allocate a database, you're going to get at least two files. You get a data file, which is where your data pages live, the actual rows in the tables in your database, and you get a transaction log file. And the physical transaction log file is written to disk. The default extension for the log file is .ldf. And then that physical file is divided into logical units called virtual log files. And as I said, I'll call these VLFs from here out. And VLFs are designed to be reused. So the transaction log is designed to be a circular file. And I'll demonstrate what that means in a minute. But VLFs, or virtual log files, can have one of two statuses. They can either be free or active. And if a VLF is free, it can be reused. And active VLFs contain log records that SQL Server requires. And there are a couple of different things that you can think of log records being required for. If you're in full recovery, you need to do a log backup in order to free a VLF. So if you're in full recovery and you have not done a log backup, then any VLF that has transaction records written to it will be active. And this is why, if you are in full recovery, you want to run log backups with some frequency, because it will allow SQL Server to free up VLFs. Log records are also required for any sort of high availability mechanism. If you think about log shipping, you think about mirroring or availability groups. All of those mechanisms use the transaction log to move database activity from one node to another. And so if you are running availability groups and you've got a high level of latency, you have a synchronous connection between two replicas, and there's a high level of latency, you can run into issues with the transaction log growing. And then finally, rollback, roll forward activity. If you have a long-running transaction, all of the records, the log records associated with that transaction prior to commit are going to be required, because SQL Server may need to roll that transaction back. So those are three reasons that log records can be required. And then just to give you a visual demonstration of virtual log files, this is a very simple example. I've got 4 VLFs represented. That is on allocation. Actually, I'm not sure if it's now the minimum you can get. It used to be the minimum you could get was 4. You might be able to get as low as 2 now, but either way, very simple example. So I didn't mention that you always need one active VLF, because SQL Server needs somewhere to write transaction log records. So in this case, this log file has just been allocated and VLF 1 is active. 2, 3, and 4 are free. If I begin transaction 1 and I commit it, but the log records associated with transaction 1 span into VLF2, VLF2 goes active. Then tran 2 starts, spans into VLF3, tran 2 commits. Now I have 3 active VLFs. And then finally, tran 3 starts and it spans into VLF4, but it does not commit. So tran 3 is still open, it is still doing work, and that's indicated by the arrow. So at this point, assuming my database is in full recovery, I do a transaction log backup. And because transactions 1 and 2 had committed, the log records associated with those transactions can be written to the backup, and then those virtual log files can be freed up. Because transaction 3 is active and it spans VLF3 and 4, VLF3 and 4 have to stay active. So at this point, transaction 3 continues to write. If it hits the end of VLF4, so there is no more space at the end of the transaction log file for transaction 3 to write, transaction 3 will wrap around. SQL Server will say, I've got free VLFs at the beginning of my file, continue writing transaction log records there. And then it would continue writing to the end of VLF2. And in that case, if I continued writing transaction 3 and no log backup ran, so transactions 1 and 2, they began committed, but they have not been cleared by a log backup. If I have auto growth turned on, I will extend my log file. My log file will grow, and transaction 3 will continue to write into what is now VLF5, and VLF5 will be active. I indicate a single VLF being allocated here. Prior to SQL Server 2014, when you grew the log file, it would grow in a fixed number of VLFs depending on how big your growth parameter was. So when you allocate a database or create a database, log file gets allocated and you can give it an auto growth amount. If that auto growth amount was less than 64 meg, you would get 4 VLFs. If it was between 64 meg and a gig, you'd get 8. And if it was more than a gig, you'd get 16. With 2014, they changed the algorithm that is used to generate VLFs, and based on a formula, if certain criteria are met, it will allocate a single VLF. And I'll explain why that is beneficial as we get further in. But just know that on auto growth, some number of VLFs will be allocated. So I talked about this being a case where you have auto growth turned on. If your transaction continues to write and it hits the end of the log file and you don't have auto growth turned on, so effectively your log file is filled up and you cannot write anywhere, you get one of these. You want to avoid these if possible. Commuter malfunctions are a bad thing. This can also happen when you fill up a log drive. So I've seen this happen where you have runaway activity in a database, a long-running transaction is running, or something is going on that is preventing the log file from freeing itself, or VLFs from freeing up. You can actually hit the end of the log file. And at that point, in either case, when I hit the end of the log file and I don't have autogrow on, or I run out of space on my log drive, SQL Server will stop working. It will not be able to do any sort of update, insert, delete activity. So you want to do what you can to maintain your log, and I'll talk about ways to do that and ways to prevent growth as we get further in. A couple of other points about auto growth. You want it on. You don't want to work with a net without a net. You do want to work with a net. And then you can set file growth to either a fixed amount or a percentage. So prior to 2016, the default for a log file was to set the auto growth to 10%. And basically, if you have it set to a percentage, you effectively have unbounded log growth. So the log will grow if it's a gig and you have it growing by 10%. The next time it grows, it'll be at 1.1 gig, and then that growth will keep getting bigger and bigger. So if you have runaway growth, it can blow out the end of a log drive more quickly than it would otherwise. So you want to do this. That linear growth is good, not this. That asymptotic or exponential growth, that is bad. So you want to make sure that your logs are growing by a fixed amount. And I can show you a demo, actually the results of a demo that will kind of show what the difference is in terms of auto growth. And this deals with that growth parameter. So I've run through the demo before prior to this, just because I didn't want to have you sit and watch Management Studio run an update query or insert query actually. But I've got two databases. I've got a database called BigLogDB and one called SmallLogDB. And the BigLogDB, the initial log file size is 8 gig, and it has a 1 gig log growth. The SmallLogDB, should be another L there, that has an initial log file size of 8 megabytes and a log growth of 1 megabyte. Both databases contain a table with the same schema, and I ran 100,000 inserts into both tables. The 100,000 inserts into the big log table took 8 minutes 35 seconds. The small log table, 9 minutes and 15 seconds. So small log took longer, but this is an example of how Microsoft has really improved the way that the transaction log runs. So I started writing demos about this topic on SQL Server 2008. And back then, when I ran this same example, the same demo code, the insert to the small log table would take 1.5 to 2 times longer than the big log. Because the transaction log is used in things like high availability mechanisms like availability groups, Microsoft has worked very hard to optimize log file processing and transactional processing. So with 2016 and 2017, there have been some tremendous advances made that have really improved the way that the log runs. That being said, the small log is still taking longer, and I'll explain why that is and show you how you can optimize the way that things work. So what I'm going to do now is just run this query, and these will be available on my blog, and I'll talk about that when I get to the end of the presentation. But I'm just going to run this query, and what this is going to show me is I've got 2 rows in my result set for big log, and the reason for that is that it's breaking out by the VLF status. So you can see VLF status of 0, which indicates that my VLF is free. There are 15 of those. So as I said, when I initially allocated the 8 gig log file for this database, it allocated 16 VLFs. So in the course of my 100,000 inserts, all of those insert transactions wrote into a single VLF, and it was the active VLF, and there was no time associated with log growth. My small log, which is 8 meg to start with a 1 meg growth, those 100,000 inserts generated 400 VLFs. There would have been, I believe, 4 to start, so that effectively generated or created 396 VLFs. And in this case, the log growth activity took 10 seconds. So that is one of the reasons that the time for the log write, the time for the transaction to the small log database was greater. So I've got many more VLFs. It took time to grow, and you want to try to maintain a log file with as few VLFs as possible. And the reason for that is that SQL Server does everything it does with the transaction log. And the more VLFs you have, the harder SQL Server has to work to do whatever it is doing with the log. So 400 is not out of control. The kind of general rule of thumb is you want fewer than a couple of hundred. I have seen cases in the wild with upwards of 500,000 VLFs, which is extreme, and I know people that have seen more than that. But there are things that you can do to reduce the number of VLFs, and I'll talk about a couple of examples as we go through. Something else to keep in mind, let me flip back to my slides, is that you should try to avoid shrinking your transaction log file at all costs. And there are a couple of reasons for this. One is that the transaction log grows for a reason. There is a transaction that ran that caused a certain amount of log space to be consumed. And so that can cause the transaction log to grow. And if that happened once, then it could happen again. So if you grow your log file out by 10 gig, for example, and you shrink it down to a gig, there's nothing to say that a transaction is not going to come through again and grow it out to 10 gig. Log growth is an extremely expensive operation. And one of the reasons for that is that all of the space associated with the transaction log that is allocated to it, SQL Server has to zero that space out. And to show you an example of why this doesn't happen with data files potentially, is there is a setting within Windows that is called Perform Volume Maintenance Task, and you can set the SQL Server service account, you can give the SQL Server service account permissions to perform volume maintenance task. And effectively what this means is that your data file has an auto growth parameter attached to it as well. So if my data file grows by a gig when it fills up, if I have perform volume maintenance task granted to the SQL Server service account, SQL Server asks Windows for that amount of space. It asks for a gig of space. Windows gives SQL Server the space, and it will just write to that space as it does, and it will overwrite whatever is there. And there's a disclaimer here, and this is from the 2016 install package. They've added this as an option, so I can check that box on install, and it will grant this permission to the service account. And below that, there is a disclaimer, and it says, this privilege enables instant file initialization. This may lead to information disclosure, as it could allow deleted content to be accessed by an unauthorized principal. And what that means is Windows gives SQL Server that gig of space. Because it's not overwritten, somebody can go in and look at what was on that space and potentially find some information that you don't want them to see. Because the transaction log is a sequential file, all of the space associated or allocated to it needs to be zeroed out. Because there are log records writing sequentially, there could be something on that space that looks like a log record. And if SQL Server is writing transaction log records and all of a sudden it hits something that looks like a log record but is not in sequence, you will get log file corruption, which is the worst kind of corruption. And so to prevent that from happening, SQL Server will zero out all of that space. So if you think about a gig of space, that is 1,048,576 bytes. You multiply that by 8, you get the number of bits, and each one of those bits has to be zeroed out. So if my log file's grown out, I shrink it down, it grows out again. SQL Server has to go through that process of zeroing out that newly allocated space, and that's extremely expensive in terms of memory, processing, and I/O. So highlighting those last 2 points, you want to avoid shrinking the log because log growth is extremely expensive, and that space must be zeroed out because that space must be zeroed out. The one instance where you do want to shrink a log is if you have a database with a transaction log file that has grown and you have a very large number of VLFs. The way to remediate that is to shrink the log file down and then grow it out, and it will basically right size the VLFs. One way around this is to have an idea of your transactional volume and the size of your transactions, and try to size your log files appropriately on the front end to prevent runaway log growth and log consumption. So why not to shrink your log? And now I'll talk about log space reservation. And this gets into the idea of batching transactions. So as I said before, transactions are all or nothing. And because a transaction could potentially have to roll back, SQL Server, in addition to the space that it's using to write log files, it's also reserving an additional amount of space in the event that a transaction has to roll back. And this reserved space is released on commit. So the average amount, it's usually about 50% of the space that is being consumed by the transaction will be reserved. And when the transaction commits, that space will be released. So this is a reason that you want to batch your transactions. And kind of a real world example of this that I've seen more than a couple of times is you have an application, the application processes orders. And historically, the business has said, we want to retain 2 years worth of order data. And then at some point in the future, the business decides that we really don't need 2 years and we're spending money storing the records associated with that 2 years of data. We want to change that retention period to 2 months. And so somebody comes in and writes a delete statement that looks like this, where they're going to delete from the orders archive table where the order date is less than 2 months ago. and they run this in a single transaction. All of that activity has to complete before the transaction can commit. So not only is it holding the VLFs open, but it is reserving potential rollback space for all of those deletes. And to give you an example of what this looks like from a demo perspective, so in this case, I have a pair of databases. I've got a database called LoopTran, and I have another database called OneTran. And you can see them over here. And then I've got a table in each one called Loop Table and OneTable, and they have the same schema, and they each have 100,000 rows in them. And I've run this on the front end just so you don't have to sit here and watch Management Studio clock. What I'm going to do is I'm going to run two different scripts, and they are both going to update all of the rows in that table. So they're going to update all 100,000 rows 10 times. And for the OneTran database, those 10 updates, so updating all the rows in the table 10 times, are going to run in a single transaction. So you can see that this while loop is wrapped in a begin transaction and a commit. And then the LoopTran is going to run the same 10 updates of the entire table, but each of those updates is going to run in its own transaction. And I'll run those in a second, but what I'm going to do while that runs is I'm going to capture the activity associated with those transactions. And I'm going to write them into a temp table, and I'm going to grab a couple of different pieces of information. I am going to grab the number of log records that are being written. I will get the number of log bytes used. So this is the actual space consumed in the log by the transactions. And then finally, I'm going to get the number of bytes reserved. So I'm going to run this in an infinite loop, and then I will kick these two scripts off. And I highlighted something I shouldn't have oughta. So we're going to let that run. And this should run for about 13 seconds, 8 seconds. My server is bigger than normal. And I will run the LoopTran. And this should run in less time, hopefully. So it ran 2 seconds less. It ran 6 seconds. So I'm going to stop the execution of this code. And then I'm going to run a select against the temp table that I wrote into. And there are two different selects, one for OneTran, the other for LoopTran. And what you'll see is that, so the single transaction that ran 10 updates of all the rows in the table generated about 1 million records. It used about 151 megabytes of space, and it reserved 319 megabytes of space, which kind of puts the lie to what I said about half the space being reserved. This is reserving almost double. But I'm not sure why I'm only getting 7 rows. Finish. Yeah, ran 10. I'm not sure why this is only generating 7 rows, but we'll roll with it for right now because it still demonstrates what I want to talk about. But effectively, so it's reserving the 319 megabytes, and it's holding on to that space for the duration of that transaction. For each one of these rows, it is reserving about 1/10 of what it reserved up here. So if I had seen all 10 of these numbers would add up to about 151. And then if all 10 of these had showed up, the megabytes reserved would add up to about 319. But the difference is that as each of these transaction commits, that space is released. So effectively, each one of these transactions is reusing the same reserved space. And so it will prevent log growth by minimizing the amount of space that's being reserved. And so this is why when you're writing code, if you are affecting a large number of rows, you want to try to avoid doing things in one batch. And so you can do things like in the example that I had back here, instead of running this delete all in one shot, do something like delete a top. So delete top 5,000 or 10,000 and run a loop to do that. Or set the date threshold and decrement it. So delete 30 days worth of data and then 30 days worth of data, and break those transactions up. Because one, it will prevent log growth because your transactions will be shorter and transaction log backups can free up VLFs. And secondly, it will minimize the amount of space that you're reserving. So that's log space reservation. Last topic I want to talk about is rollback. And so we talked about log space reservation being reserved for rollback. And the way that rollback works is an anti-operation is generated for each forward operation. So for an insert, a delete will be generated. For a delete, you're going to generate an insert. And for an update, you'll generate an update. And we'll jump right back into the demos. So I'm going to create a table. The table is going to have 1,000 rows in it. Table's got a clustered index. And I am going to run an insert into that table. And I am going to begin the transaction. I'm going to run 1,000 inserts, and I'm going to roll those 1,000 inserts back. And before I do that, I am going to grab a value from a table valued function called fndb log. fndb log allows you to read the transaction log file, and it's a table valued function, which means that I can run a select against it, just like I would a table. So I'm selecting the max current LSN, with LSN standing for log sequence number, from the log prior to my transactional activity. So this is going to grab the last row in my log, and then after my inserts run, I am going to run another select against fndb log using that max LSN as a starting point. So I'm going to run these transactions, roll them back, and then it is going to insert into a temp table everything associated with a series of operations in the log where the object I'm affecting is the index associated with my table. So I'm going to run this. Hopefully it will not take too much longer. I've got too many result sets. So this is a count of the different types of operations that are going on in the log. And you can see I did inserts, and I did 1,000 of them. And then when I rolled it back, it generated 1,000 deletes. And you can see the description is compensation. And that's how SQL Server refers to the rollback activity, is compensation. So you can see that it's generating those 1,000 deletes. You can do the same thing for deletes quickly. It's the same concept, and as I said, these scripts will be available. And if anybody has any questions about this, my contact information is in the slide deck. Feel free to ask me, because I like to talk about this stuff and my wife doesn't. So any and all questions are welcomed. And here you can see I've got 500 deletes and 500 inserts as the anti-operation, the compensation. And then finally, just the example of updates. And the anti-operation for an update is another update. So you've updated the value to a new value. When SQL Server rolls it back, it updates it back to the previous value. And here you can see The modify row is the equivalent of an update. Got 1,000 of them, and then I've got 1,000 compensation updates. So is the demo for rollback activity. I'll take questions in a minute. There's a couple of resources. If you do a search for transaction log architecture, Microsoft has some great documentation that goes into more detail about VLFs and how the log file is architected. And then most of the stuff that I've shown you in here, I've learned from Paul Randall. Paul Randall is my SQL Server hero. And this is a link to his blog with the category transaction log. So Paul helped ran the team that wrote the storage engine for SQL Server 2005. And so much of this is working with code that he helped to write. And so his blog posts on the Tran log are the most comprehensive out there, I would say. So that is what I've got. I think I'm right at 45 minutes or so. So
Yeah, you are right at 45 minutes.
awesome.
So I'd like to thank you so much, Frank. Now we can open this up for questions. We've had about 56 people on the call so far. And I just want to encourage anyone, if they have any questions about transaction logs, VLFs, new acronym I learned, this is a great time to, ask Frank these questions and get those, answers, and whatnot. So no questions. Oh, here we go.
All right.
Okay, so we've got a question. It says, how do I monitor what the typical log file size is so that I can determine if and when processes are scaling outside normal bounds?
So, I mean, basically you can monitor, there are a couple of ways to monitor log growth. I mean, one, you can monitor the physical size of the file. If you're talking about monitoring VLF usage, there is a function, a dbcc command called dbcc log info. I should probably put this in a demo so I don't have to type. Don't tell Buck Woody, Jen. Let's see, I think that's the name of one of my databases. So, and this is actually in a couple of the scripts where it's being dumped to a temp table. That's how I'm getting some of the information that I show you. But this will dump out information about all the VLFs. So my one Tran database has got 8 VLFs. You can see that there are 8 rows returned. File ID is always going to be 2. Your transaction log file, the first transaction log file will always have a file ID of 2, and you should only have one transaction log file. Reason being that because it's a sequential file, you're only going to use the second, third, any multiple files when the first file fills up. And if you're maintaining the transaction log effectively, you should never need to write to a second file. It doesn't give you any performance benefit. You can write to multiple data files and you can parallelize and do some cool stuff, but file ID is always going to be 2. And then this status will show you whether the VLF is active or free. 0 is free, 2 is active. And this parity bit is one of the things that SQL Server uses to determine if a VLF is available to be written to. So that's how you can manage, or monitor VLF usage. As I said, in terms of monitoring file size, you can actually monitor the physical file size of your log file. And then there is an event that writes to the default trace that will tell you if your log file has grown. And you can monitor log file growth that way. I don't have a script for that, but if you want to shoot me an email, I can send you some example code as how to do that. Any other questions?
That question was from Seth Bauer. We've got another question here. Michael asks, Jankila asks, or Yankila, How small to shrink a log file if fixing the problem of a large number of VLFs?
So the examples I have, always shrink it as small as you can get. So shrink it to a meg. That can be difficult in certain cases. If you have a very active log, it can be hard to get it that small. Usually what I'll do, and I've got example code for this as well if you want me to send it to you, is I will run a transaction log backup in the same, I'll do it from a query window, and I'll run the transaction log backup in the same query window as the shrink, because that will, basically run in a single batch, and we'll take the transaction log backup, it'll do the shrink. There have been, I've had experience where I've had to do that multiple times to get it to shrink, but usually after 2 or 3 log backups, it will free the VLFs and allow you to shrink it. And then you want to grow it out to the desired size. So in a lot of cases, I work with clients where we'll come in and do a health check, find out their log file has 30,000 VLFs in it. And so you shrink it down. And if the log file is 16 gig, you grow it out. There's a really great link, and I should put it in my resources section. I don't know if I'll be able to update the slides before they get made available, but Kimberly Tripp has a great blog post about that process. And there are a couple of caveats around how you want to grow your file and the biggest growth you want to use. So I'll try to get that in the deck, but shoot me an email and I can send you examples of how I do that.
Great. We've got a couple other questions. The next one, thank you, Michael, for that question. We've got Shrikant has got a couple of questions. He says, my transaction logs groups larger than the data file we use merge replication. How can we keep tabs with it? He said, follow up, the only option he sees is to shrink the file since it eats up the whole disk.
Yeah, merge replication is a little bit outside of my wheelhouse, but it's using the transaction log. So I don't know how you can remediate that. I can find out. I'll do some research. Shoot me an email with that question and I'll get you an answer.
Okay, I'll make sure we do that.
Okay.
The next, so thanks, Shri, for that. Let me send that out. We've got another question from Justin Limbeck. He asks, do indexes on a table also affect rollback performance? Would we expect a slower rollback as more indexes exist?
Yes. I mean, basically, you think about it in terms of, indexes are there to help reads run faster and they can slow down writes. So rollback is effectively write activity. So it's going to, the same hit that you're taking on the initial transaction, you're going to take that on the rollback. And that's something else I didn't mention regarding rollback activity, is that SQL Server can run parallel. So if you set your max degree of parallelism to 0, SQL Server will take advantage of as many processors as it can see, and it will split a load up and parallelize it across multiple cores. Rollback is a single-threaded activity. So if you are doing, and as a production DBA, I've had this call more than once in my career. The application calls and said, we kicked off a delete at 8 o'clock this morning. It's 3:30 in the afternoon and the delete's still running. Can you kill it? Now you can kill it, but it can potentially take as long, if not longer, for that rollback to happen. So just something else to keep in mind about rollback. But to the question of indexes, yes, more indexes can slow down rollback activity because that write has to, those writes have to cascade through the clustered index to all your non-clustereds.
That makes sense, even for me. And he said, Justin says that answers his question and answered his next question. So that was a 2-for-1. Good job.
Awesome. And they say the best questions are the ones that are on the next slide. I guess the best questions are the ones you answer without them being asked.
I love that. That's fantastic. So we still have a few more minutes. We've got 5 more minutes on the line. Any other questions that we might have? I'm noticing several folks are a little bit, let's see, Fernando, any questions? Or I'm randomly shouting out names here. Cindy or Carl or Calvin, Beverly? Always fun to hear your name called out on a webinar, right?
So while waiting, this is my email address and my Twitter handle are both up on the screen. You can hit me up at either place with questions. And as I said, the joke's getting old now, but I like to talk about this stuff and my wife doesn't. So any and all questions are welcome. If you don't have a Twitter handle, just a little bit of a plug for the SQL Help hashtag. There is a hashtag #SQL Help on Twitter. You can post questions there, and some of the best and the brightest in the world will be out there answering them. Paul Randall, Kimberly Tripp, Alan Hurt, the list goes on of people who monitor SQL Help and will answer questions. That is, it's a really great resource. And if you can't fit your problem into 280 characters now, you can post it to a forum and then tweet the link to the forum, your forum post.
Awesome. Well, we do have one last question from KT Srinivas. Any suggestions on placement of transaction log files?
So I generally suggest separating them to their own drive. Historically, if you go back 15 years when all storage was local, the reason that you did that was because the right activity of a data file and the right activity of a log file are completely different. A data file is being written to randomly, where a log file is being written to sequentially. So you wanted to prevent contention between those two activities with a spinning disk. So now everybody's got SAN, and most SANs have SSD cache. So you're splitting disks up, and you're potentially going to have the same LUNs or the same drives being carved up into LUNs, and you're also not dealing with the spinning disks. But you still want to separate that because the access paths to those drives are separate. So you're still dealing with random versus sequential writes, and by splitting them up, you can improve performance, even though you're potentially writing to the same physical storage. So that is my rule of thumb, is to split log files and data drives or data files onto separate storage.
Okay, well, we'll make that the last of our questions. Looks like KT got his question answered. Just stay tuned, everyone. So the next session coming up is a preview on Azure Data Factory version 2, early adopters with Joseph Bart. And then we can go to the last slide. And I just want to thank everyone for attending. And I'd like to thank Quest for being our presenting sponsor. And I hope that you tune in to the next 24 hours of past session.
And if you can fill out your evaluations, they help me get better. If you had something you didn't like, tell me what you didn't like and why, and I can get better next time I do this. So thanks a lot.
Yes, great plug. Please do fill out the survey as you close this window. And thank you everyone for your time, and have a great day, evening, morning, whatever time is going on at your time. Thanks so much, everyone.